All right, good morning. Just want to run through the density altitude calculations briefly, hopefully briefly. Three things we need to solve for density altitude problems are the current atmospheric pressure expressed in the altimeter setting. We find that from the altimeter setting. We need the airport elevation, which may be given, or maybe you need to go to the chart and find the airport elevation. So you may need to learn how to read sectional charts, aeronautical sectional charts, to find the airport elevation. And of course, you need a METAR report with the ambient temperature. Actually, the METAR report will give you the atmospheric pressure, altimeter setting, and the ambient temperature as well. So you need those three things. The whole point of this exercise is to graphically demonstrate the density altitude issue. Density altitude, as you see on the left side of the chart here, or the graphic rather, as temperature gets warmer than standard, warmer period, the density altitude is higher, which means the aircraft has less performance. Or if the pressure gets less, the aircraft has less performance. And the reciprocal is true as well. Temperature getting cooler tends to decrease density altitude. So density altitude means the air is getting thicker as the temperature gets cooler. Or if the pressure goes higher, that also decreases density altitude. In other words, the air pressure is thicker and better performance. So density altitude is a measure of a way to sort of judge the performance of the aircraft in a general way. High density altitude is bad. Low density altitude is good. Okay, but we need three things to accomplish that. So we're going to look at the problem here, and the problem is calculate density altitude of Boise Airport, BOI, on a day with the temperature listed from Figure 12 in the testing supplement, FAA Testing Supplement. It's Figure 12. It's a METAR, right? So we need to be able to interpret METARs as well. So these kind of questions on the FAA written test will challenge chart reading, weather interpretation, METAR interpretation. So anyway, we have three choices: 6,500, 1,200, 3,200 feet. So right off the bat, we look at the temperature, 17 degrees. Well, what is the standard temperature? 15 degrees. So 15 degrees would mean a pressure altitude of sea level. So it's warmer than 15 degrees, so it should be higher, depending on the temperature, it should be higher than the airport elevation. So the airport elevation is given as 2,871 feet. So probably B is not correct, but we have to calculate the temperature now, and the pressure. We have to put the pressure in there. So let's before we jump to conclusions, probably A or C, but till we solve the problem, let's be careful. First thing we need is to look at the METAR, find Boise. There it is there, BOI. Then we look over and start interpreting it, all right? So we know that this METAR is for Boise, BOI. The METAR was issued at the 12th of the month at 1845 Zulu time, wind 130 at 4 knots, 30 statute miles of visibility. Scatter clouds at 15,000, 17 degrees C, 6 degrees for a dew point, and altimeter 3015. Great. So we have those things, right? I've circled them there. 17 degrees, 3015. So that's the two things we need, and also the question gives us the airport elevation. So those are the three things we need. Simple. So we come up to the right-hand side of the chart to find the pressure altitude first. That's always what we do first, have to find pressure altitude. And we look over there and we see we've got the altimeter setting, 3015, and we go down to the left-hand side of the chart and we see altimeter setting 3010 and 3020. Well, 3015 is not listed. It's got to do some calculations to know, extrapolate the halfway point. So I put the calculations up there, halfway between 165 and 257. You just add the two numbers, divide by 2, it comes up with 211. 211, there's an error you may notice right about is that you look over there and you see there's minus signs in that. Well, what is that saying? That is saying that the air is thicker with the higher pressure. So you need to subtract that number because that's a conversion factor from the airport elevation. That's what's not listed on this chart. You have to be careful not to confuse with this, but so you need to take the 211 and subtract it from the airport elevation. Airport elevation was given in the question. You see the bottom there, I've got it written, airport elevation 2,871, so you have to subtract 211 from that to get 2660. 2660 would be the pressure altitude. Capiche? Okay. That's what I've got listed here in the bottom here. So we took 2871, subtract 211, you get 2660 is the pressure altitude. So that's what we're solving on this right-hand side of the chart is for pressure altitude first. Right? Pressure altitude conversion factor minus 211, airport elevation 2871 equals 2660. I know I'm going through fast, but this is a video, so you can pause it if you need to catch up here. All right, I don't want to make a 45-minute video on this. Okay, so now we've got the pressure altitude. So what do we see on the left-hand side of the chart? We see these perpendicular lines, and they're labeled pressure altitude in feet. Okay, so we've got 2660 pressure altitude in feet. Next page. Okay, so now we have the temperature. So temperature correction, we can go to that next. We know that the question says that the METAR said it was 17 degrees C was the pressure, or was the temperature that day. So we find on the bottom scale, you got C, Celsius, F, Fahrenheit. Make sure you're on the right scale. Slide over till you come to 17 degrees, just a little past the 16 degree mark, and draw a line straight up from there. So as you draw the line straight up, and you see the, let me get my highlighter pen out here. We use green, I guess. Right, so we find there's the 16. No, that's no good. That's nasty, but okay. Maybe I want a pen. A pen, yeah. So, oh, highlighter. Here we go. This is what I really wanted. So we go slide up that line there. Just draw a line all the way up. Doesn't really matter. Just want to draw a line up there. That represents the temperature correction. Okay. So we start with the right hand. Now we're on the left hand side of the chart. We have the pressure altitude. That's the next page. So now we see these lines says pressure altitude in feet. We said the pressure altitude was 2660. So we find the 2660 line and we make that line right there. Now I wasn't all that accurate with this. I used about 2500. Right? So I could have been a little higher with that line. But we see that there's an intersection between the two lines. That's important. So we draw the line representing pressure altitude, which we calculated from the right side of the chart, pressure altitude of 2660, which, yeah, it's really hard to find the line, so I give myself a pass on that. That's okay. So we take that, after we've drawn those two lines, we go to the next page, and, well, we notice that over on this side of the chart, it says density altitude correction. That gives you density altitude over here, so all we need to do is go from that intersection of those two lines, go straight over there, and that gives us the approximate density altitude. Okay, what have I got there? About 3,000 feet. So I go up to here to the answers and we go, well, we already decided that probably not 1,200 feet. Got two choices. Well, which one's closest? Obviously 3,200 feet, but that's still a significant number. That's quite a bit higher than the airport elevation. The airport elevation was 2660. Now we're a few hundred feet higher. The air is thinner, performance is less. So again, we start on the right-hand side of the chart and we make the correction or the conversion factor, find the conversion factor for pressure altitude. So we have the airport elevation and we have the altimeter setting. So you take the altimeter setting, and in this case we had to extrapolate between 3010 and 3020 to come up with the correction factor for 3015, and we come up with a minus 211. We applied that to the airport elevation to come up with a pressure altitude of 2,660 feet. Then we went to the left side of the chart. We can do it either way. You can do the temperature first, or you can do the pressure altitude first. Really, either way. it's okay. If you do the pressure altitude first, you just draw that line right there. That red line is sort of hard to see, but that represents the closest I could come up with to 2660. And then we go to do the temperature. Again, we can do it either way. Find the temperature of 17 degrees. See, we got both. We got that from the altimeter setting correction over here, and the temperature from the METAR, or was given to us in the question, possibly. We do that correction, and then we interception of both lines. We go to the left side, because that's this chart here is the solution to this is approximate density altitude, and so we find that, and we come up, at least when I did this, I came up with 3,000. That's one of the three choices. We already decided B was probably not right. Could have been A or C. C is the closest. C is the answer. Hopefully this will be helpful in further examples that you might come about. But that's basically way to go through this. So, okay, thank you.